For part 1, let us first try to find when the particle is going to be crossing the y-axis. So for that to happen, we are going to let its x-coordinate be equal to 0. And the x-coordinate is defined in terms of the parameter t, which means that we will be letting t cosine t to be equal to 0. So the product of this and this is equal to 0. This simply implies that t must be equal to 0 or cosine t must be equal to 0. When t is equal to 0, both x and y are 0. That was when the particle was at the origin. So it has not moved yet. So this is not where we are going to be looking for when the particle first crosses the y-axis. Our answer should lie within here. So letting cosine t to be equal to 0, we know t is equal to either pi over 2 or 3 pi over 2 or 5 pi over 2 and so many other possible values. But since the question asks for the first time when the particle crosses the y-axis, so we know that t must be equal to pi over 2. And we're supposed to find the equation of the normal. So we need to gather a few more pieces of information. One of the things that we will need is the expression for dy dx. So to find dy dx, let's first find dx dt. So dx dt, using the product rule, it is going to be t, then minus sine t plus 1 time of cosine t. So this is going to be equal to cosine t minus t sine t. We need dy dt also. So using the product rule again, differentiating this with respect to t, it is going to be t cosine t plus 1 time of sine t. So this is equal to t cosine t plus sine t. And this can help us to deduce the expression for dy dx. And that is dy dt divided by dx dt. So it is going to be t cosine t plus sine t. This is going to be divided by cosine t minus t sine t. So now we have all the expressions that we need, and let's try to find the rest of the information that can help us to deduce the equation of the normal when the particle first crosses the y-axis. So when particle crosses the y-axis, when the particle first crosses the y-axis. So when a particle first crosses the y-axis, that is when t is equal to pi over 2. And the x-coordinate is equal to 0, obviously, because it is crossing the y-axis. And the corresponding y-coordinate, let's go for t to be equal to pi over 2. That will be pi over 2 sine pi over 2. Sine pi over 2 is equal to 1. So y is going to be equal to pi over 2. This gives us the y-intercept. What we need is the gradient of the normal. And to find that, let's make use of dy dx. So dy dx is going to be equal to, replacing t by pi over 2, we have this cosine pi over 2 plus sine of pi over 2. This is going to be divided by cosine of pi over 2 minus pi over 2 sine of pi over 2. Cosine pi over 2 is 0, sine pi over 2 is 1. So 1 divided by, this is 0, then minus pi over 2 sine pi over 2 is 1, so we have this. And this tells us that dy dx is minus 2 over pi. And now I guess we have enough information to find the equation of the normal. So let me write it down. The equation of the normal when the particle first crosses the y-axis will be y is equal to, the gradient of the normal is going to be negative 1 over the gradient of the tangent. So that will be pi over 2x plus the y-intercept, which is pi over 2. And now we are looking at when the particle is going to be crossing the x-axis. And that is when y is equal to 0. So by letting t sine t to be equal to 0, we will be able to know when the particle will be crossing the x-axis. So it will be when t is equal to 0 or when sine t is equal to 0. we'll be ignoring the time when t is equal to 0, because when t is equal to 0, just like what we have discussed in part 1, that was when the particle was at the origin. So this is not what we are looking for. As for this, t can be equal to 0. Again, this is not what we are looking for, or pi, or 2 pi, 3 pi, and so on. So for this, the second time when the particle is crossing the x-axis will be when t is equal to 2 pi. This was the first time. So when t is equal to 2 pi, let's try to look at the instantaneous speed. So when particle crosses the x-axis for the second time, crosses the x-axis for the second time, that is when t is equal to 2 pi. And for the instantaneous speed, it is expressed in this way. So we need dx dt, we need dy dt. So when t is equal to 2 pi, let's work out what is dx dt. Dx dt, making use of the expression that we have found in part 1, it is going to be cosine 2 pi minus 2 pi sine 2 pi. Sine 2 pi is 0. So we are going to be left with just cosine 2 pi, and cosine 2 pi is 1. Let's see what is dy dt. Dy dt, making use of the expression from part 1 also, it is going to be 2 pi cosine 2 pi plus sine 2 pi. So cosine 2 pi is 1. I'm going to be left with a 2 pi here. Sine 2 pi is equal to 0. So dy dt is this. And now we can find our instantaneous speed. So instantaneous speed. Instantaneous speed, it will be equal to the square root of dx dt square. So dx dt is 1. So we have a 1 square plus dy dt square. So it will be 2 pi square. And this will give us the instantaneous speed when the particle crosses the x-axis for the second time. And that is 1 plus 4 pi square. To check whether the particle will ever come to rest, that is when the instantaneous speed is equal to 0. So let's try to see whether it is possible for us to analyze whether it is possible for the instantaneous speed to be equal to 0. So for the instantaneous speed, let me write it down, instantaneous speed. This is equal to the square root of dx dt square plus dy dt square. And let's make use of the expression from part 1. It's going to be too long expression, especially we are going to be doing a square to both. So let me draw a super long square root here. So this is going to be cosine t minus t sine t square plus dy dt square. So we have a t cosine t plus sine t square. Let's expand this, which will be a cosine square t minus 2t sine t cosine t plus t square sine square t. And expanding this, we will have a t square cosine square t plus 2t sine t cosine t and a sine square t. And we will square root this. Let me write a super long square root over here. So we will square root this. And if I were to just group the terms together, some things that we can see that will be cancelled off, which is this, and this is going to be cancelled off. I'm going to group this and this together because sine square t plus cosine square t is going to be equal to 1. So it is going to be sine square t and cosine square t to be grouped together. And I'm going to group this and this together and factorizing out t square. Because by doing so, factorizing out t square, I will have a sine square t plus cosine square t too. So plus cosine square t. And we will square root this. And we are going to be left with an interesting expression that will actually help us to make this decision. this is 1 plus this is 1 t squared. So we have an expression that is bigger than 0 for all real t. So t belonging to all possible real numbers. In fact, t must be bigger than 0, right? But anyway, this is going to be bigger than 0 for all real t. So it is impossible for the instantaneous rest to be equal to 0. And that is why the particle will never come to rest.